Hello everyone, this is Rohan Kokula. Welcome to my another video of COVID-19 playlist. Please go through my previous videos on data gathering and Tableau predictions for detailed explanation of this video. In this video, I'll be showing the effect of lockdown in India, number of cases per lockdown phase, and visualization of different zones declared by government, that is red zone, green zone and orange zone. By end of this video, I'll be covering why final year exams should be cancelled in Maharashtra. This video won't be too long, so watch it till the end. I've created Tableau public dashboards so that you can download them and use it on your Tableau software. You'll find these links in the description. Let's start with lockdown analysis. Here, this curve indicates the total confirmed cases in India in a cumulative manner. The data is retrieved from covid19india.org. You can get the files from their API website. I've used the national level time series data. So if you'll select it and drag it to the tabs, we can see that this is a dictionary. So to convert this dictionary into a data frame, we'll be needing normalization. We'll also be needing the zones JSON file to visualize the zones in India. As this is a dictionary, a key value pair is generated, where district is the key and the name of district is the value. Similarly for state and zone. I have created a Jupyter notebook to download files and normalize it and also export them for visualizations in Tableau. You can get this notebook from the GitHub link provided in the description. Download this notebook and get along with me. Firstly, I have imported all the necessary libraries such as pandas, JSON normalize, requests and datetime. Requests is used to download files from URL. Let's run this and check the data. Here, the data is in a key value pair, that is dictionary. The same goes for zones. We need to convert this dictionary into our pandas data frame format. JSON_normalize is used to convert the JSON format into the pandas data frame. Let's compare the data type of zones and zones_df. Type zones and run it, and then it gives the dict as the data type. Similarly for zones_df, this returns pandas data frame. Let's check the daily df data frame. It shows the daily count and the total count of a particular date. The problem with the date column is that it doesn't include year. We need to explicitly add 2020 to each of the string. We'll be iterating a for loop over all the rows. df.ilog gives the location of that particular date. So I is the rows and 3 means the column number which starts from 0. So 0, 1, 2, 3. For I equals to 0, the data of 30 January will be as 30 January 2020. As this column consists of all the strings, we'll be converting this date string into the date time object. So next line will do the work. Let's check the updated data frame. The date column represents the standard format of a date. We'll set date as the index for daily df and we'll export this into the CSVs. So the CSVs are generated and we'll use this CSVs for our Tableau software. Let's select daily cases as a text file for the connections. As date was set as index, it will automatically sort in an ascending order. So the last entry was on 11th May. Here's the dashboard I've created. This looks a bit messy, but if we'll open it in presentation mode, this becomes sorted. It all began with a 14-hour Janta curfew on 22nd March 2020. First lockdown started on 24th March till 14th April, that is of 21 days. On this day, number of confirmed cases were 571. By the end of this lockdown, number of cases rose to 11,485, that is increase of 10,914 cases in 21 days. As you see, this curve just started to increase. Then there was an announcement on extension of this lockdown till 3rd May. This lockdown was further extended to 17th May on 30th April. So lockdown 2.0 had 23,000 cases in 16 days till 30th April. If you observe, the rate of lockdown 2.0 was 1.5 times of lockdown 1.0. Let's move further. Since the lockdown period has extended till 17th May in India, it's 11th May today, the time of recording. So I forecasted this graph for 36 days from today. Here you can see by 17th May, the number of cases reaches to 92,771. If you'll observe, lockdown 3.0's increasing rate is almost 2 times as the rate of lockdown 2.0. First case was recorded on 30th January 2020. I've plotted a mark for the first 1 lakh cases. It shows that it took 110 days approximate for the first 1 lakh cases. That is from 30th January till 19th May. There seems no hope of getting this curve flattened. I've created a mark on 2 lakh cases of this estimated curve. This shows that 2 lakh cases will be reached by 16th June 2020. I've created a mark on 2 lakh cases. It shows that it took 28 days for the next 1 lakh checkpoint. Let's increase this forecasting period to 2 months. The alignment of these labels got disturbed due to the scaling. This estimation shows that around 3 lakh cases would be reached by 11th July. That is in just 15 days. The increasing rate at this particular duration is very high, and this is the exact duration where Mumbai University is conducting final year exams. In this duration, there would be around 5 to 6,000 cases per day. And if even a single student gets affected with coronavirus in this duration by giving exams, then university will be responsible for this. They have specified July 1 to 30 as the duration for giving exams. Let's change this duration to our forecasting period. Let's select 3 months as the forecasting duration from today. Number of cases from 1st July till 30th July increases from 2,59,000 till 3,36,000. Now let's start with the zones CSV. I've created a separate dashboard for the description of these zones. There are some particular conditions set for each zone, such as districts with higher than 80% cases in each state is considered as red zone. If there are no new cases within 14 days in a red zone, it turns into orange zone. Districts with no new cases within 21 days is declared as green zone. Here's the district-wise distribution of green zones in India. This map is created by dragging longitude to the columns and latitude to the rows, and then dragging the state dimension to the details section. I've created calculated field as measure for each of the zones. The logic is taking this zone column from the data frame. Let's see. So this zone column includes only three types: green, orange and red. So I've specified green, and this converts it into a boolean expression and returns the int and then sums it. By applying this measure to the state dimension, it gives the district counts of green zones in a particular state. If you observe down here, it says 98 unknown values. So these are the districts which are not recorded in the Tableau software. Let's check this. So it shows 98 issues for the district and 1 issue for state. This is because latitude and longitude of respective districts in our data is not mapped into the Tableau software. You cannot say how many zones are there in Maharashtra. So by filtering it, it shows only the Maharashtra state's district with a green zone. To simplify this map, I have created another map on states basis. So this gives number of zones in that respective states. Similarly with the orange zone. Here you can see most orange zones are in UP, of course. Here's the district-wise distribution of red zones. There are more red zones in the Maharashtra and in the UP region. Let's check it state-wise. Again, UP being the highest and Maharashtra being the second highest in terms of red zones. Such illogical decisions are taken by Mumbai University. As some of the restrictions are lifted by now, we can see great increase in the graph. So stay home and stay safe. Thanks for watching. Please like, share and subscribe.